Hey, in this class, I will talking about how to prove that two functions are inverse. And now you will see now the definitions to prove is two functions are inverse. Now two functions f and g are inverse functions if and only if both of the compositions are the identity functions. The identity function is x. Then if the function f and the function g are inverse functions if and only if when you find f composed with g, the final answer is x, and both conditions, both of their compositions are identity function, and g composed with f is the identity x. Using one example, I'm going to show you how to apply this concept to prove is two functions are inverse. One example. Suppose I have now my function fx. My function fx is 3x plus 9. And my function gx is 1 over 3x minus 3. And the question is determine whether each pair of functions are inverse functions. Can I say that g is the inverse function of f? Can I conclude that the f is the inverse function of g? Then, according to this theorem, I need to find f compose g. And I need to find g compose f. If at the end, in the both cases, in the both composed functions, the answer is the identity function is x, I can conclude that f is the inverse of g and g is the inverse of f. Okay, starting with this. Now, this is f and the g is 1 over 3x minus 3. And now, using composite function, this is 3, 1 over 3 x plus 9. Okay? And when you do this one, it is plus is 1 over 3. I'm sorry, here, let me erase this. I make a mistake here. It's 1 over 3x minus 3 because this is g plus 9. And now here it is x minus 9. 3 times 3 is 9 plus 9. And finally, x 9 minus 9 is 0. I have x. Now, when I say f composed with g, my final answer is the identity functions. What happens when I say g, when I find g composed with f? Now I have g, f is 3x plus 9, and I substitute 3x plus 9 in g. Now it's 1 over 3, 3x plus 9. Remember, I change the x here by 3x plus 9. Minus 3. And now 3 divided by 3 is 1. And 9 times 1 is 9. Divided by 3 is 3. Minus 3. And finally x. Okay? In both cases, now f composed with g is equal g composed with f, and they are both the identity function. Then I can conclude that f and g are inverse functions. They are inverse functions. Remember it again. two functions f and g are inverse functions if and only if both of their compositions are the identity functions. You have two functions. To prove that they are inverse, you need to find the composite. F composed with g and g composed with f. And a both composite function have to be the identity functions. Okay? We're going to do another example. How you do another example? Using another example, let me find another problem. Suppose you have f, let me read with this way. Black. I like it to use a black color. And the function fx is equal 4x squared. And a g is 2 square root x. And the equation is determine is this pair of functions are inverse. Remember, we need to find f composed with g, and I need to find g composed with f. Both composite functions have to be the identity function. Now, come on. g is 2 square root x. And now I substitute this on the x. Now 4 is 2 square root x and square. Finally is 4 times 4x and is 16x. Then you see in this case 16x is not the identity functions. Then we conclude that the f composed g is not equal the identity function. Then because they are no identity function, f x are not inverses. Because to be inverses, the composite function had to be the identity functions. This is the way to prove is two functions are inverse. The functions are inverse. Thank you very much. Watch this video. Have a nice day.